All right, so welcome to mostly the last session in our build Golang applications using test-driven development series. We started this series by trying to build a grep-like application in Golang, and we wanted to support basic functionality like searching from a file name, searching a string given a file name, so that the program will read the file, search the string, and print the results. We also implemented searching by from the standard input, and we also implemented searching recursively directories, right? The way we did this is via test driven development. Although there is a bunch of things to further improve in the program, uh, we focused on a lot of uh, more than the code itself. We focused a lot also on the approach as to how do we approach programs when we do test driven development, and we broke the problem down into uh, smaller subparts. We focused on the processing part of the problem than the inputs and the outputs, etc. Right? So what we want to do in this video is to summarize what all we've learned so far. So I've taken notes from all the previous videos and just sharing them here so that we can walk through them real quick. So the first idea about any new problem when we encounter is to really understand it deeply. What we mean by understanding deeply is try to break the problem into kind of three parts. What is the input to the program or the problem? What is the output it produces? And what is the processing required to transform the inputs into outputs? Any application that we typically develop can be categorized into this kind of problem statement, where there are inputs which produce with given some processing, these produce some outputs. So the idea and one of the most important parts in a problem is the processing part, where which is where the TDD allows you to focus more on, and it removes the extraneous data like inputs and outputs and the way they are represented. So specifically in this Golang like grep case, we purely focused on just the grepping functionality. We didn't worry about how do we parse the CLI, how do we print the output, what if you want to print the outputs a file or different things. We just focused purely on what is the core crux of the problem, which is the grepping functionality or searching functionality, and we implemented that. So that is what TDD allows us to do, and it's a very strong and really powerful design technique to use. Then the other thing that TDD allows you to do is use you can either use a top-down or bottom-up methodology for solving the problem. Top-down usually means you go from you build the end-to-end functionality, or you write the test case such that it covers more like end-to-end functionality. Okay? And in the bottom-up would mean you assemble things from small functions, and you already have a predefined idea on the kind of functions that you need, and then you assemble them later, right? So typically I have personally used top down mainly, and that has worked well for me, because as we do top down, we discover more unknowns. With bottom up, you are almost forced to understand and discover this upfront, or they just come to you naturally. The next thing that we did is find out unhappy and happy path for problem statement. So in case of this grep, it meant what happens if the file doesn't exist. We've noted these down into some sort of test cases, right? Like what if the file doesn't exist? What if there are not enough file descriptors? What if it is not text file, permission errors, directories, things like that, right? So identifying happy and unhappy paths for your code allows you to reason about the edge cases as well. And uh, what I fundamentally believe is QA typically is considered as a role in software. Instead, a QA is a mindset, and every developer should adopt a QA mindset to actually uh, look at the error and positive and edge cases as well. So that is what we did. One of the most important parts of writing code is expressing the intent. That is why we focus a lot on variable naming, method naming, struct class naming. Does it actually convey what we want to build, right? Uh, and another idea is to use the names from the problem domain as much as possible. So this is also referred to as a ubiquitous language in domain driven design terms. This typically translates in practice into using variables like say the function name that we use grep, right? Instead of using search string or search something in something, etc., we just use the domain terminology, which is what we're trying to implement. So it starts with as simple as that, essentially. Identifying and handling errors, I think, doesn't need any more introduction. So for functions that return arrays, then we looked at adding test cases for checking 0, 1, and many. This is again important for any collection, anything that returns a collection. It could be map, list, slice, whatever. We usually check for nulls if it's possible in the language. If not, then check for zeros, ones, and many. Right? One other thing to remember is, garbage in, garbage out, right? That is why we want to validate method params, especially public APIs. That way, if you don't accept the garbage, then you won't produce the garbage, right? And that way you can depend on the code to do these validations beforehand. Then we talked about this making the assumption explicit. In the context of grep, it was primarily about what do we do? Do we assume the current working directory? Do we assume relative paths, etc.? Right? So that is primarily sort of lessons, and these translate into some of the test cases that we later refactored into code. Yeah. In the next part, with other thing that we learned with TDD is the whole red-green refactor cycle. Right? So you first write a test case, it will not even compile mostly, right? And then you make write just enough it's just enough code to actually make it compile. The way you start the test case is using given, whens, and then, right? That's how we typically divide the test code. And the one of the most important parts is whenever the test fails for the first time, is it actually failing for the right reason, right? Or is it because you have written the test case in the wrong manner, right? So a failure for the right reason is one of the first things to check. If it is failing for the right reason, then you can make it pass, and then the next stage is a factor cycle. Okay. So we've conveyed this earlier already. Again, the test naming convention that we use is typically that will give you enough context when the test fails on the continuous integration system, right? Then we learned how to write table-driven tests in Go, and we learned how to create various scenarios and run each scenario in a test case as a separate test case of sorts. That way, we get the code reuse as well as we get the readability of the test case. Yeah. We touched upon the problem of functional core and imperative shell, which I covered earlier as well, which basically means we focus on the core important processing functionality of the problem, this input, processing, output, this processing part, and just that. And then the other parts, which are like inputs and outputs or any other things that are not core to the problem, we leave them to be implemented later, because they will actually not determine the problem or code design as such that much. Yeah. Then in the next sort of long video, we this was an interesting one where we looked at how do we write test cases for standard input. We realized that standard input can be overridden. Like you can actually, because this is where the power of interfaces comes into picture and abstraction comes into picture. You can abstract the standard input into behind the interface and use that interface as a string reader or whatever, right? This will allow you to create a unified interface for your code. This was again an interesting video. Then in the next one, what we looked at primarily is it was more like brainstorming, I think, in this video, where we talked about how do we really design right interfaces. And usually it is not that they will not just come to you once. You will mostly have to iterate. So it may be okay to actually write some code, go ahead, proceed, and then come back and refactor the code. That is usually the better practice. And the reason why we write test cases is so that we can fearlessly refactor the code, right? Then the next thing is, in the next video, we look at value as a boundary. What that means is we identify structs. So this is where really designing right function signatures is important, where how do we identify what is the function, what is the API for each function, what is the signature for each function, what is the input, what is the output, why it is so, and how that will help us compose that function to other functions, or how will we be able to use that function throughout the overall functionality of the program, right? Again, one rule sort of to follow is don't overthink, keep it simple, stupid. First of all, like make it work and then make it better, especially in that order, because uh, this is where the art part of software comes into picture, where if we try to solve two problems together of writing the code, the best possible code in the first go, it usually doesn't work that way. If you talk to any writers, any painters, designers, they will tell you, in order to produce the final book, final design, they had to they had to go through multiple iterations, and programming is quite like that, at least in my opinion. Then on the code side, we looked at the file path.walk directory function, how it works and how we use that. We are able to use this to recursively traverse the directory structures. It allows us to also handle the errors. We can capture error as a value and return errors so that we can use those in the test case for assertions, etc. Later, so this is where we are able to have bunch of test cases for example, not matching, then a single match, multiple match. So this is the array related case. This is a case where there is no file doesn't exist. Then there are various other cases uh, for recursive searches, and this is where things got sort of complicated. And in the last video, what we did is we okay, so in the second last, yeah, we understand this. We haven't solved yet. We understand the challenge of opening and closing a file. For now, we are keeping this as an open exercise for the viewers. Uh, we uh, we also had to decide how we want the results to be, grep to work, right? So we decided that from the caller point of view, it will have a blocking API that it will return all the results in one go instead of returning them in a streaming fashion. And internally, it will actually implement in future Go routines. So that was the conclusion that we had to come to. And in the last video, we refactored the the basic code into Go routines and channels and wait groups. So up to this point, what we did is we applied the same tactic that we show here, that first make it work and then make it better. So at this point, we have a recursive implementation working, but it is not using Go routines. And in the next part, we see a potential to use Go routines to make the program run in a more concurrent fashion. So that is when we refactored code into Go routines, channels, and wait groups. So overall, this has been the journey for building a real world like application using test driven development. There is a bunch of other parts that we haven't done, which are actually mentioned in the problem statement, which is basically like running the program, right? By passing some inputs and then seeing the output. As we said, we primarily focused just on the processing part. We have not implemented the binary. We haven't handled any flags. We haven't handled any output, etc. But we could easily write that, and then the core logic of this will still remain same. Especially if you look at the test cases and the code, uh, the act of grepping can be potentially used to into any program. It doesn't even have to be a CLI. It can be via a web search. It can be via a web crawling of a URL, or reading some data of sockets or streams, right? As long as it's the textual data. So that is what we were able to do, because we just focused on the core of the problem and not on the external factors, the imperative shell part of it. All right. that is it that we have. In the next series, we will maybe start a new series for database schema design and maybe REST API design as the next series. Right? Any questions from anyone? Any comments so far? All right, cool. Then I think, yeah, that's it. We will not what we can do is we'll push this repo and make this public as well, so that and I'll put a link to that video description, just to include the link as well, so that it's easier for people to follow the final code and take it up and make it better and write the CLI part if they want to. Yeah. All right. I With that, thanks a lot.